So we'll start our introduction to linear algebra here by introducing you guys to the concept of matrices and vectors. So a matrix is just a collection of elements arranged in rows and columns. So the rows are horizontal and the columns are vertical. So a matrix is typically notated in square brackets and they're typically uppercase. The individual elements inside of a matrix are notated with subscripts. So for a matrix there's two subscripts, I and j. The first is the row number and the second is the column number. So for instance, A21 can be found in row 2, column 1. Vectors are just a matrix that only has a single row or column, and most people might have more familiarity with a vector than a matrix just beginning. But they are notated in curly brackets and are typically lowercase. So you may see a vector in a class like statics or dynamics where it represents a position or an acceleration in 3 space, x, y, and z. So b might have a component in the x direction of b1, and in the y direction b2, and in the z direction b3. But a vector is just a simplified form of a matrix. So the size of a matrix is given as the number of rows by the number of columns. So the matrix B here has 2 rows and it has 3 columns. So we would say B is a 2 by 3. C here has 4 rows and 2 columns, so it's a 4 by 2. X is a column vector and it is a 3 by 1. And then Y is a row vector, so it has 1 row. It's a 1 by 2. Quick introduction on some special square matrices that we'll see later on in linear algebra. A square matrix has the same number of rows as columns, so C is a 3 by 3. A diagonal matrix only has non-zero elements on the diagonal, so the diagonal is running from top left to bottom right. The upper triangular matrix only has non-zero values above and on the diagonal, so everything below the diagonal has to be 0. And a lower triangular only has non-zero values on the diagonal and below, so everything above has to be 0. The identity is a special type of a diagonal matrix in that every element on the diagonal is equal to 1. And then lastly we have a symmetric matrix, and a symmetric matrix is symmetric about the diagonal, meaning that if you were to fold this matrix in half about the diagonal, the elements that would then touch each other are equal. So in this case 5, 5, 6, 6, and 5, 5. So what we can say here is that C21 is equal to C12, C31 is equal to C13, and so forth.